Hello everybody, and a warm welcome to the International StarT-Gala from my behalf as well. My name is Ida, and I am here today to bring you greetings from the Chemistry Lab Gathering at the University of Helsinki in the form of a little science show. And actually, in honor of all of you, today's participants and winners, I made you a little painting that I am going to reveal right now. Ta-da! Fabulous, isn't it? Now you don't have to lie to me, because to be completely honest, I was in a little bit of a rush when I made this. So it still looks kind of boring. So as much as I do love purple, as you can see, we might add a little bit of color to the painting. It still quite doesn't do it. Maybe this might help? Yeah, it's a lot better. Yeah, I think we have concluded that art is probably not the right career path for me after all. Chemistry, however, might just be. The painting that we just created was not made with any regular paints. Instead, what I used was blueberry. And bilberry to be exact, works as a natural indicator. And indicators are substances that change their color based on the chemistry of their surroundings. In the first glass right here, we had a solution made with baking soda. And baking soda is actually basic. And in the second one, which is empty now, but there we had vinegar, which is acidic. And they are the substances that caused the nice color changes. Bilberries, however, are not the only natural substances that can work as indicators. I also brought with me some juice made with red cabbage. I'm not going to drink it, however, because, we're in the lab. I'm not supposed to drink anything that is found in the laboratory. It wouldn't be safe. But what I can do with it is that I can pour some of it right here. And to that, we add a little bit of sodium hydroxide. Which turns the red cabbage juice green, meaning that sodium hydroxide is actually basic. Now, to top things off, we can still add one magic touch with dry ice. The reason for the further color change in the red cabbage is that dry ice is actually made out of carbon dioxide that usually is in a gaseous form right in the air. We actually breathe out carbon dioxide. So carbon dioxide, when put in water, actually partly dissolves as carbonic acid, which makes the solution acidic. You might also want to ask, what is that little cloud that surrounds the dry ice? It's literally what I just said. It's a cloud, because dry ice is so cold, minus 78 degrees Celsius to be exact, so cold that it can freeze the moisture in the air surrounding the dry ice. So what we see here is actually tiny little particles of frozen water. Dry ice is not the only extremely cold substance that I brought here today with me, because I also got you some liquid nitrogen. But for that, I will need some further protection. Looking good. Nitrogen is also usually in its gaseous form, actually making up most of the air that's surrounding us. And liquid nitrogen is even colder than dry ice, because it is minus 196 degrees Celsius cold. So if you guys were here with me today physically, I would ask for a volunteer right now. Who would want to volunteer? Okay, right. Your job is to put your hand into the liquid nitrogen. Got it? No, you don't actually want to put your hand into liquid nitrogen. That would be a horrible idea. But luckily, I got a stunt hand here with me. It's a rubber glove filled with water, because most of us humans are actually made out of water. So let's just dip that right in there. Looking good. Can you hear that? Fingers frozen solid. So yeah, you would definitely not want to put your own hand into the liquid nitrogen, because your fingers would freeze. We might also want to add there another rubber glove that is not filled with anything. Almost feels like grilling, you know. And what would a festival be without some balloons? You might want to cover your ears for this one. Ready? 3, 2, 1, go. It doesn't quite seem to pop. But like, something's happening to the size of the balloon instead. the air didn't actually go anywhere from the balloon. Instead, the colder a gas is, the smaller of a volume the gas actually takes, and vice versa. The hotter, the more volume the gas picks up. And as we can see, the warmer the balloon gets, the bigger it gets again. This also applies for metals. Here we have a little ring and a little ball. And the ball can pass through the ring with ease. However, let's also freeze the ring a little bit. Just will not go through. And now we've almost achieved the end of our show today, but I still have one little gift for all of you today's winners. You might have seen the rose here on the table with me all along. And that rose is for you. My name is Ida from the Chemistry Lab Gadolin, and a really huge thank you and huge congrats to everybody at the festival today. This rose is for you.